In this lesson, we're going to introduce this concept of electron configurations. Now, electron configurations, the word configuration refers to how electrons are arranged and organized in an atom. And this is something that's a little bit complicated, and the pattern isn't exactly intuitive. And so we're going to use a college dorm as a bit of an analogy to get us there. Obviously, the college dorm is not an atom, but it gets us an idea of sort of how this works, and then we'll see how to adjust the analogy to make sure that it fits how an atom actually organizes. So to kind of take a look at this again, let's read this first sentence. We'll learn how electrons are organized based on the quantum mechanical model of the atom. So again, what they decided upon in terms of using quantum mechanics to decide how electrons are arranged. We will use floor plans of the dormitories at Quantum University, go fighting photons, the finest institution in all the land. So you'll be in charge of essentially assigning residents at the dorms here. There are 4 types of rooms. You can see here you got the suite rooms, party rooms, den rooms, fun rooms, and the significance really is the letter here. You have S, P, D, and F kind of rooms. And there's also a couple of rules with which you have to assign these residents that are going to be assigned to these rooms. So here are the 3 rooms, or the 3 rules that you'll be using. The first one is simply called the Aufbau, the A-U-F-B-A-U, the Aufbau. You're going to fill in from the bottom floors first, and then you're going to fill upwards. Another residential advisor that you're going to be working with is Mr. Pauly, who tells you that each dorm room, we're going to fill the top bed first, and then we're going to fill the bottom bed. Right? So effectively, these are bunk beds. You're going to fill the top bunk, then the bottom bunk. These can be represented by just drawing an up arrow and then a down arrow for the bottom bunk. It makes sense to a certain degree because you don't really want to assign 2 people to the top bunk. And then the third one here, Mr. Hund, says that in a group of rooms of the same type, residents should not be paired until all the rooms have at least 1 resident. Each resident will want to have their own room as much as possible. You can imagine, right? Each room is going to have 2 people living in it. And if there's some patterns that allow you to have single residents, right, those single residents would appreciate it. Now, again, there has to be some suspension of disbelief here, guys. This isn't exactly how dorms are assigned, but you kind of get the analogy and how this works. Okay, let's go ahead and walk through these. I've given you floor plans here for 4 floors of a room. Just know that this, or of this dorm can technically go on for forever. But we're just going to focus on the first couple of floors here. And kind of notice that each floor has some different systems or different rooms there. So the first one, first floor, you can see here, this is boxed off area. This is the only room that's there. This is the S room. And again, just kind of giving it the college feel. We'll just say that all of this out here, this is a dining room area, right? The second floor, you see that you have the S rooms, right? So S shows up here and here. But it also has these P type of rooms also that show up, and there's 3 of them. Interesting. But this space out here, I don't know, maybe this should be like the lounge area. We have some nice chairs and ping pong tables and whatnot you can just hang out at. The third floor, you have the S type of room. You have 3 of those P rooms, but then there's also a third type of room, of which there are 5. So there's D, 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 D. Right? So you can see that you have the S room, the P room, and then the D room starts showing up on the 3rd floor. And this empty space here, I don't know, we'll just say like the laundry rooms or something. Right? Got to keep your clothes fresh. And then the last floor that we're going to talk about today, it does have the S, the P, the D, and the F type of rooms, which is new, and there's 7 of them, right? So there's 1, 3, 5, and then 7 of these rooms. That's going to end up being sort of how this floor is arranged, and this space here, maybe some like study tables or something like that, right? Of course, reserving the smallest space for the studying that happens here. So in this, again, sort of setup here, notice how the actual rooms that we're assigning residents to are just denoted with the letters. And we're going to start assigning them based on the rules. So I'm going to scooch up just a little bit to remind ourselves of some of these rules. First of all, the first one says we're going to fill them from the bottom floor first, and then we're going to start working our way up. So we're going to go to the first floor, right? The first floor makes sense here. There's only 1 room on the first floor, and so for this one, we're just going to represent it simply by doing a little up arrow to say, hey, that's my first resident. It's going to go there. And then the second resident is going to then be paired up, right? Nothing else on this floor is possible for you to assign another resident. So we're just going to go ahead and pair those 2 up, all right? Now, once you finish up the first floor, we then move on to the second floor, right? It doesn't make any sense to skip to the 3rd floor or the 4th floor right now. So on the second floor, let's go and see what we have here. I'm going to go and assign my first resident again to the S room. It's the biggest room. It makes sense to have someone be in the largest room as possible. And then your next residence, you got to be careful here. I want to look at Mr. Hun's room. It says in a group of rooms of the same type, right? And so there's only one of this type of room, right? Residents should not be paired until all the other rooms have at least one resident. So of this same type, there's no other S rooms. So our next resident will actually be paired up here. Now, I want you to kind of notice this. It seems kind of sort of like a extra effort to try to figure out where residents are assigned, but then at the end of it, you'll see that it all looks the same. They all just got assigned. But so let's actually kind of pay attention to the pattern, because this next one is where that pattern of filling and assigning residents really becomes important. Because it says, again, in a group of rooms, in this case you have 3 of these rooms. So this group of 3 rooms, residents should not be paired until all the other rooms have at least one resident. So my next resident I'm assigned is going to go here. Where does the next one go? Well, I'm not going to assign it here, right? Because that means that you've broken Mr. Hun's rule. We're actually going to go ahead and assign our next one, not to this spot, but instead to the next room over. And then we're going to assign the next one after that to this one, right? So we're going to have an up arrow because we have to assign the top bunk first for this room, then up arrow for this room, and then the third up arrow for that room. Now, once we have the next resident we need to assign, that's going to go here, here, and then here. So, as I just mentioned, the rooms and how they're assigned doesn't look like much once you're done, but remember the pattern of assigning is what is most important here. Let's go and take a look at the third floor. All right, so we're filling up the first and second floors, done. The third floor now is next. Let's go ahead and do this room. It's the biggest one. Let's go and assign a resident there. The next one goes here. You have a group of P rooms, and you have this group of D rooms that we haven't seen yet, but again, the pattern is more or less the same. First is S, and then we go to P. So we do up, and then up, and then up, right? Mr. Hun says that these rooms should not be paired until all the rooms have at least one. And then you have down, and then down, and then down. Right, we filled all the P rooms on the third floor. Let's now take a look at the D rooms on the third floor. So here, same pattern, right? I'm going to assign my first resident here. And then because Mr. Hun says I have to keep other rooms occupied at least before you can pair any of them, I'm going to go ahead and add the rest of the residents there in that order. And then I'm going to come back and assign the bottom bunk to be paired up. And then, of course, the last floor, you can kind of get the pattern here. You go up, down there because that's the first room, the biggest rooms. Those get assigned first. Then you have the second room. Excuse me, I should not have paired that. The second rooms, you go up, 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 down, down, down. And then the D rooms up, 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 down, 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 down. And then to finish it out, you have this new type of room, the F rooms. And these all get their electrons assigned in that exact pattern. So that's effectively how this analogy is going to start off. Right? We assign it in this pattern based on those rules. Let's go and do a little quick check of our understanding here at the bottom and try to answer these floors. How many total residents can live on the third floor? You can go through and count it. 1, 2, 3, 4, blah, 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 blah. It actually ends up being 18. There's actually some significance to that number. We'll talk about that later on. You might be able to bridge that with something you learned before. If you have 33 residents, which floor will the last resident live on? All right, so effectively, I'm just going to go through and count out where the 33rd resident will be. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, so on and so forth. There's a lot of counting that goes on. I can tell you right now, it's going to be on the 4th floor. Will a resident occupy a 4P room if a total of 30 residents are assigned to the building? All right, so 4P, right? 4 referring to probably the end or the floor right here. You see that? And then one of these P rooms. So will the resident occupy a 4P room if a total of 30 residents are assigned to the building? All right, well, again, if you go through and start counting, here we go. 1, 2 residents, 3, 4, 5, 6, 7, 8, so on and so forth. And you keep counting up to 30. Well, as you start counting, you'll actually realize that the 30th resident will be this one right here. And just for the sake of changing colors to make sure you know what I'm talking about, this one right here, that's the actual resident. That'll be the 30th one. Will a resident occupy any of these rooms? No, actually, we're kind of just short of it. So the answer to that would be no. If you have 14 residents, will that 14th resident have a roommate? Well, again, some of you are like, okay, well, it's paired, obviously, so if it's an even number, then yeah, it should be paired. But of course, you have to pay attention to the way that they're assigned, that the rooms are the pattern of filling. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So right now, these first 10, of course, they're all filled, so there's no need to worry about that. But over here on the 3rd floor, let's go see how that 14th resident is being assigned. So we have 4 more to go, right, on the 3rd floor. So we have the up and then the down, right? And then over here we have up and then the up. So this one right here ends up being the 14th resident, and so in this case it should be no, right, because that's going to have its own sort of pattern of filling according to the Hund's rule. These two, of course, cannot be paired, so that's why they're assigned to different rooms. I'm going to go ahead and let you guys try out 5 and 6 on your own, just to kind of get the feel for how this works and to be able to count this out yourself. All right. Now, to actually bridge it then, to kind of make sense of how this actually works, we're going to see that this isn't exactly the actual pattern. This is just an analogy to get it started, and there's going to be an adjustment we have to make. Let's start off by connecting what we just learned to the actual chemistry. First of all, each floor is the equivalent to each energy level, right? So each floor effectively represents each energy level. If some of you want to bridge that with the Bohr model, that's basically each ring, right? So each floor represents each ring. Each room, right? So each room, so each individual box, that's going to be an orbital. Right? So this is an orbital. These are where the electrons are found. And then a group of rooms of the same type are described as this new term, which is degenerate. Degenerate, degenerate. These rooms, again, of the same type, let me kind of bring this back up. So just to highlight this, what I mean by that is that this, for example, these rooms are considered to be degenerate. There's 3 degenerate p orbitals here. There are, kind of highlighting these, there are 7 degenerate f orbitals on the 4th floor, on the 4th energy level. Right. So these again have, these are described as the word degenerate. Let me highlight this just so you can reference it later. 3. Blank. Electrons are assigned starting with the lowest, not blah, blah, blah. Lots of stuff here, so let me go ahead and start filling this one out. This first one is going to be called the Aufbau principle, right? That's the Aufbau, AUFBAU, that we saw earlier, so the Aufbau from the previous page. This one called the Aufbau principle, where it says electrons are assigned starting with the lowest energy orbitals, right? Orbitals. So the lowest, we're going to start by assigning electrons starting with the lowest energy orbitals, not energy levels. So just to kind of be clear about this, we're going to be doing these by orbitals, not by floors, effectively. We're going to be doing this by room type, not by floors. Again, it makes intuitive sense to go floor by floor, but based on quantum mechanics and whatever rules that are dictated from that work, it actually shows that the energies can be calculated, right? So you can calculate these energies, and then they're assigned based on this pattern. Now, this pattern of knowing what the lowest energy orbitals are and then going upwards, that's not intuitive, and that's where we use something called the diagonal rule to help us out. Diagonal rule. So the diagonal rule basically, it starts off looking like this guy right here on the right. What you'll notice is that you have a couple of rows. So we have 1s here, 2s, 2p, 3s, 3p, 3d. So notice each row starts with the same number, right? That number then reflects effectively the floor or the energy level, right? Because the first floor only has the s type of rooms. The second floor has the S type of rooms and the P type of rooms, right? The third floor has an S, the P, and the D type of rooms. So just to refresh your memory here, right? The first floor has S type. Second floor has S's and P's. Third floor has S's, P's, and D's. So basically, this is just an introduction, just kind of getting us oriented here. And the diagonal rule basically says that we're going to start from the bottom right to the top left, according to the arrows I'm going to draw here. So it's going to be kind of a strange set here, but basically what I'm showing you is that this is the order in which you assign electrons, and kind of have to follow this sort of a 45-degree angle as you go through these. Starts off with 1s, right? And we assign electrons to the 1s. And then we kind of sort of visualize this swoop coming back around to do the next diagonal, right? So this is the first diagonal we assign electrons through. The next diagonal goes here. The next diagonal goes here. And then we follow this next diagonal to start assigning electrons. Now, again, this might not make a whole lot of sense just yet, but when we start looking at this in practice, we'll see how this works. Please do note that each type, each number of degenerate orbitals depends on the letter that's there. So S type, right, there's only one orbital or one box, one room. The P, there's 3 of them. D, there's 5 of them. F, there's 7 of them. So going back up here, right? S, there's 1 of them, right? Only one room. P, there's only 3 rooms. D, there are 5 rooms. F represents 7 rooms, or there's 7 F type of rooms. 7 types of orbitals, or 7 orbitals of the F type, excuse me. Now, the last bit here, to kind of get us rolling on the next couple of terms here. Number 4, this one right here says blank. Electrons must have different spins in the same orbital, represented by the direction of the electron arrows. And the word spin, it probably doesn't make a whole lot of sense right now, but just know that it's technically a term that we have to acknowledge, but we're not going to get into what exactly it means and how it affects the electrons. This one's called the Pauli exclusion principle, P-A-U-L-I, exclusion, E-X-C-L-U-S-I-O-N, and then principle, P-L-E ending. So effectively what we're saying is that when you assign electrons to one orbital, right, they have to be in opposite directions. The spins are in opposite directions like that, kind of like how we drew the top bunk and then the bottom bunk. But they can't be both top bunks and then both bottom bunks. So the word spin, again, not really a whole lot of meaning that we're going to get out of it for now, but just recognize that that's something you have to consider when you start assigning electrons. And then finally, the last one here, number 5, this is going to be an electrons, blank of course. Electrons are not paired in an orbital until all degenerate orbitals have at least one assigned electron. So this is what that whole deal was when we basically went up, 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 and then came back and did down, 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 right? So we didn't always just go up, down, up, down, up, down, up, down for every single room. And this is called the Hund's rule, right? H-U-N-D, Hund's rule. So to kind of illustrate this idea, and you've seen this before, so I want to make sure we're clear about this, but this example here says let's assign 7 electrons to these orbitals below. So you see here, right, I have the 1s box, I have a 2s box, I have 2p box. Remember, there's 3 of them, right? We kind of covered that before. So on the second floor, there's 3 p type of rooms. And we're going to basically assign 7 electrons, but the way it's supposed to be done, of course, is going to look like this, where it's up and then down, right? Fill the first floor, do the second floor, and then that's 4, so we have 3 more to go. So it's going to look like this, where we again don't pair them up until all of the degenerate orbitals, all 3 of these have at least one. So it's not going to look like this, which is probably what our intuition would tell us, to do this and then assign these last 3 like that. Okay, that's the basis here. We'll kind of cover the rest of this and do some more practice with it next time. That'll do it.